Thank you. Thank you. Okay, I'm Matthew Clark. I'm a scientist with Elsevier. I work with our customers to use our products and other products to do things like predictive modeling, solving problems. My background is in pharmaceutical research and software development. So today, though, we'll be talking about predictive modeling of on and off target bioactivities. So as a scientist, especially those worried about bioactivities such as drug discovery and drug development, some of the issues are you need to make the best possible decisions to rank or decide on drug candidates and use all the available information to help make decisions. And all available information, of course, means everything anyone else has ever published or said about different kinds of drugs, activities on targets, their properties, things like that. So just to cut directly to the summary of what we'll talk about, we've been working on some projects that we can build hundreds of predictive models for on and off target activities. There are lots of papers and people have studied particular models for specific targets, like a one-at-a-time activity for a target model for something you're really interested in. But because of the breadth of data that's available today, we can build many, many models to look at on and potential off-target activities, as well as selectivity of compounds, which can be very, very important. So to do that, I'll describe a model building engine. I used KNIME. There are other tools that one could use, but KNIME is very convenient to make models for large lists of targets using data from Elsevier's Reaxys medicinal chemistry. So the kinds of models you can make are selectivity panels that I'll show you. Actually, kinase panels is what I'll be looking at today, but it's not really limited to any particular target type. Toxicology pathways and pathway analysis, I'll talk about that a little later, connecting specific bioactivities to specific toxicologies to get a prediction of risk for a particular result of inhibiting a particular target. And also PK-ADME models. We can build those. We have lots of data about that too. So again, a quick summary is I used a database we have. I'll talk a little bit more about it in the next slide, Reaxys medicinal chemistry. It extracts bioactivity measurements for thousands of targets extracted from patents and journal articles. The patents are very important because nowadays, especially in pharma, there's not as much a hurry to publish things in journal articles, but people really do have to patent things to get their intellectual property covered. So many of the most current information will now come from patents instead of journal articles. And also, of course, there's a great deal of information coming in from patents. So in the data that I'm using, each measurement is associated with a chemical structure that was assayed to create the bioactivity measurement. And so we'll combine the structures and activities to make quantitative structure-activity relationship predictive models. And I'll go through a little more detail on that, what kind of descriptors and statistics that we're using to make those. So here we're using a KNIME automation workflow to demonstrate a system to make these models. And of course, not all the models you make are predictive if you have a large list of targets, because for various reasons, because of the diversity of the molecules, the amount of the data. But part of the automated workflow is a mechanism to evaluate whether a model made is predictive and discard models that are not predictive. And each target can take, depending on the amount of data available for a particular target, between 2 and 15 minutes to create. So it will just run as long as it needs to, depending on how many targets you want to make models for and create these models. So using these tools we have with KNIME and the data in Reaxys medicinal chemistry, it's a very flexible workbench for exploring QSAR because of the diversity of targets and properties that are in there, not just bioactivities. We also have, but I won't show models made from them today, half-lives of excretion, metabolism, hepatocyte metabolism, things like that. And if you use these systems using KNIME and also the popular BioVia product, Pipeline Pilot, you can integrate these systems with in-house structure activity databases, measurements you're making in your own projects to augment the data that you're creating with the data that's been reported in patents and literature. So just one slide about our Reaxys medicinal chemistry, which is the data source that I used. It has about 35 million bioactivity, 30.5 million bioactivity data points, 6 million compounds, 13,000 targets, which is a lot, and species. It differentiates the species of each target as well, and also the mutants in many cases of the targets in case you need to study the effect of mutations, which can be important especially for kinase research. We collect everything, all of that data that's in the publication. So that comes from a large number of patents, articles, and journals. So I just wanted to, for the bioactivity, it's not just IC50s and KIs and things like that. It's also, as I said, half-lives and LD50s and many other kinds of measurements. So it's a great data source for making models, and the breadth of the number of targets makes it very interesting.